Okay, welcome. This is a quick demonstration of the MATLAB program for the final project for computer simulation. My name is Nick DiPietro, and I will be showing you my code. So we will get into it. This is just a quick overview of the code. And so initially I'm going to run this code and I will show you what it does. So I'll run the code and basically this is it. There is 4 different types of stress and strain. As you can see, there's an axial loading, torsion, bending moment, and transverse shear. The following equations for each of the 4 types of stress and strain are, the equations are shown here on the bottom. And for the engineer or for the user who's using this, can quickly note what type of input is needed based on the wording. These definitions here are straight from the textbook, and these are basically the exact definitions needed. So as you can see here on the right side of the input boxes are the some diagrams that I personally wanted added because when an engineer, when we work calculating stress and strain, we want to see and we want to understand how can we quickly analyze, say if we're calculating a moment for bending moment, which direction it is, what is the area, what is the stress, or for say axial loading, understanding, hey, what is the area, what is the force needed, or for transverse shear, understanding the direction and the y bar prime, and etc. So to run this code, we can say we'll let a 100 kilonewton force with an area of 0.1, and relating to this equation here, we see that force over area, it will take the input from force and divide that by area, and we should get 1,000, and we do. And so say for torsion, we'll do just the same 100, and we'll say our distance is an inch, and our polar moment is 1 inch, and based on this equation, we will get this answer. And we'll say we have a moment of 10, and we'll say we have a distance of 10, and our moment of inertia is 1. And if from this equation, we should get 100. And the reason why it is a negative sign is because due to the equation of moment, we assume that the direction of the moment is negative as it is downwards. So as for the following equation, we can calculate our final transverse shear, and all our inputs will be calculated with the calculate button, and they can be cleared out because for combined loading or areas of stress and strain, which we use as engineers, we sometimes would like to recalculate axial loading in the x direction or the y direction. So having this, maybe we want to keep torsion, maybe we don't, maybe we want to keep torsion and transverse shear. So we'll say, okay, we'll clear the bending out, clear the axial loading, and we'll calculate bending and axial loading in different areas. So we can change up the numbers here and calculate stress in a different area. We can clear out each and every single one of the input boxes. So that is the GUI. And I will just go over quickly of how the images show up. Basically here, these images, IMRead will read the image and it will show the image based on the axis. All these images will quickly load once the GUI is ran. And to calculate, just say for a quick example of stress, we know that if I were, let me see, if I were to show you the tag for this GUI, one second here, the calculate button, which is this here, as this tag calculate, will execute knowing that this here, this input box, this edit box is a force, which will, we can let F equals this, and handles force for string, and A equal area, in which one will calculate the area based on this edit input box. And to calculate, basically executing that the calculate button will perform F over A, which is the force input divided by the area input. And we can let the output answer be displayed once the calculate button on the division box. So that is basically the code. The 4 calculate buttons, calculate 1, 2, 3, and 4, will each have their own equation. As you can see, this is the equation for torsion, and so on and so forth. That is basically the code, and that's it. So thank you for watching, and hope you enjoy.